Let us discuss this result of limit of a vector valued function. What is meaning of vector valued function? It is a function which is defined from Rn to Rm. So here what we have, f is a function, okay, f is a function defined from S. Actually S is a subset of Rn to Rm. So this is a vector valued function we have, and f has m number of components, as you can see here, f1 of x, f2 of x, and so on, fm of x. Okay, so this is result of limit. So this result says limit of f is L if and only if limit of fi is Li at x is equal to a. That means limit of f1 is L1, limit of f2 is L2, and so on. Limit of fm is Ln, okay, at x is equal to a. So if and only if is there, that means if first part is true, then second part is true, and conversely also we can write if the second part is true, first part is also true. So we have to prove this result. So what will we do? We will assume one part first and we will try to prove the second part, okay, and then we will discuss a converse part of this one. So let us start to do it. So first of all, I will assume, okay, assume that limit x tends to a, f of x is equal to L, right? So see, we have this thing we have assumed, and I will write what we have to prove. That thing also I will write here. To prove that, what we have to prove? To prove that thing we have to prove, limit x tends to a, fi of x is equal to Li, and this thing we have to prove for all I running from 1 to m. So as you know, the definition of, in definition of continuity, we have epsilon and delta. So here I will assume one epsilon first and I will try to find delta, okay, for which it will be true. So let epsilon greater than 0 be given, okay, let epsilon greater than 0 be given. So we can use our given information, that means the information which we assume. We have limit x tends to a, f of x is equal to L. This is the information which we have assumed, this thing we have. So see, by definition we can write, therefore for given epsilon, but instead of given epsilon I will say for above epsilon, since one epsilon we have already assumed. So therefore I can write for above epsilon greater than 0, there exists delta greater than 0 such that, what can I write? I can write, use the definition of limit. So that means 0 less than or equal to norm x minus a less than delta implies norm f of x minus L less than epsilon, right? So see, this norm, actually the domain is subset of Rn, okay, domain is subset of Rn. So here I should write norm M, and codomain is a subset of Rm, so I should write here norm M, okay. So by definition I could write this. So let us start to solve this one, okay. Let us see what will happen. Here I will write implies, okay, I'm going simply solving that one, that norm. So norm f of x means what? f1 of x, f2 of x, and so on, fm of x, right? Sorry, this one, okay, minus L. What is our L? L means L1, L2, and so on, Lm. L1, L2, and so on, Lm, right? Norm complete less than epsilon. Implies, do you know how to subtract? How to subtract one number of Rm, okay, from another number of Rm. So how to subtract? Component wise subtraction we have to do. So let us subtract component wise. That means f1 of x minus L1, f2 of x minus L2, and so on. Finally we will have fm of x minus Lm, okay, so less than epsilon, right? So component wise subtraction I have done. See, actually the space is finished here, so we will require some more space. So make a screenshot of it. I'm going to remove the complete question, and after that we will continue. So please make a screenshot of it. Okay, so let us continue. So implies, what can I write? Implies, see, let us use the definition of norm. Norm is, that means square root of first plus square of second and so on, okay. Let us do that. Square root of first component, that means f1 of x minus L1 square plus and so on and so on. So last component I can consider fm of x minus Lm square, and this is less than epsilon. So to remove the square root, I will take square of both sides. So if you take square of both sides, what will happen? See, square root will get vanished. So we will have f1 of x minus L1 square plus and so on fm of x minus Lm square less than epsilon square, right? See, sum of all these is less than epsilon square. That means each of them should be less than epsilon square, since none of them is negative. So that's why first term is less than epsilon square, second term is less than epsilon square, and so on. Last term is also less than epsilon square. So let us do that. So implies I can write f1 of x minus L1 square less than epsilon square, f2 of x minus L2 square less than epsilon square, and so on. We can write fm of x minus Lm square less than epsilon square. Implies, see, I will take square root of both sides. Okay, so if you that both sides of all inequalities, so that's why we will have by considering positive square root. So that's why I'm writing mod f1 of x minus L1 less than epsilon mod f2 of x minus L2 less than epsilon, and so on fm of x minus Lm less than epsilon. This we have. So that means L1 is limit of f1, L2 is limit of f2, and so on. Lm is also limit of fn. So therefore I can write, so therefore what can we write? Limit x tends to a fi of x, okay, or so we can separate it, f1 of x is equal to L1 and so on. Limit x tends to a fm of x is equal to Lm. In this way we get, that means limits of component functions also we have got. Limit of f1 is L1, limit of f2 is L2, limit of fm is Lm. So that is in general we can write, that is limit x tends to a fi of x is equal to Li for I running from 1 to m, right? So in this way we proved the first part. In the second part, that means in the converse part, what we have to do? We have to assume this one. Limit of f1 is L1, limit of f2 is L2, limit of fm is Lm, and finally we have to prove limit of f is L. Okay, so make a screenshot of it, and after that we will go for its converse part. Let us discuss converse part now. So in a converse part, already I have written limit of fi is Li at x is equal to a, and what we have to prove? We have to prove that limit of L is limit of f is L at x is equal to a, right? So in the definition of limit, we always use epsilon and delta. So here also I will assume first, let epsilon greater than 0 be given. So let epsilon greater than 0 be given. So this thing I have assumed, right? So let us use the given information we have. So I will write, we have, what we have? Limit x tends to a fi of x is equal to Li, and this is true for all I running from 1 to m. So therefore we can use the definition for given epsilon greater than 0, but already we have taken epsilon, so I will call it as for above epsilon greater than 0. So therefore for above epsilon greater than 0, there exists delta I greater than 0. I am writing delta I greater than 0. Why? Tell me why. Because for each I, for f1 we will have delta 1, for f2 we will have delta 2, similarly for fm we will have delta m. So that's why I am writing delta I for such that 0 less than norm x minus a less than delta I implies mod fi of x minus Li less than epsilon, and this is true for all I running from 1 to m. Okay, so there is epsilon actually in definition, but a small adjustment I'm going to do. So that adjustment is epsilon by root n. This adjustment I'm going to do, as well as I would like to write one more thing, that is n, since domain is Rn. So that's why norm n I should mention there, right? So yeah, this thing we have. See, actually m number of deltas are generated here. Can you see delta 1, delta 2? This is true for all I know. So we got delta 1, we got delta 2 and so on, we get delta m also, right? So but all expression should be true simultaneously. So what will I do? I will select minimum of all these delta. So that all that inequalities will be true for that delta. Okay, so see, let delta is equal to minimum of all delta 1, delta 2 and so on delta m, right? So on all inequalities will be true simultaneously. So I consider 0 less than norm, x minus a less than delta. So we can use all inequalities here. So implies, okay, or yeah, implies I have to prove f of x minus L should be less than epsilon. This thing we have to prove. Then only we can say L is the limit of f at x is equal to a. So let us see. Let us solve it. Let us see what will happen. F of x means what? f1 of x, right? f2 of x and so on. fm of x, correct? Minus L means what? L1, L2 and so on. Lm, right? So this is equal to norm. You know how to subtract first component minus first component, second component minus second component. In that way we can solve. So therefore we will have f1 of x minus L1 and so on, fm of x minus Lm, right? Norm. You know well how to find the value of norm. Okay, so definition of norm is square root of first component plus square of second component and so on. So let us do it. So square root of f1 of x minus L1 square plus and so on, fm of x minus Lm square. But see, already we have written something here. That means fi of x minus Li is less than epsilon by root m. So that's why I could write this is less than square root of, it is less than epsilon by root m square, correct? So this bracket is less than epsilon by root m, plus second also epsilon by root m square, and this last one is also epsilon by root m square, which is equal to this is epsilon square by m plus epsilon square by m plus and so on. Last one is also epsilon square by m. So total terms we have, that is m epsilon square by m. You are getting, just like apple plus apple plus apple. If you repeat 10 number of times, you will have 10 apples. So similarly, epsilon square by m, it is repeating m number of times. So that's why I could write m epsilon square by m. So what will happen? Will get cancelled. Will get cancelled and simply we will have root epsilon square. So epsilon square and square root will cancel and we got epsilon. Okay, so that was the required thing. So we started with norm of x minus a is less than delta, and we could able to prove that thing, that is norm f of x minus L is less than epsilon. So therefore this is nothing but definition of limit, okay, in Rn, that means vector valued function. So therefore by definition limit of f is L at x is equal to a. Make a screenshot of it and after that I will write just last few sentences. Please make a screenshot of it. Okay, so let us write that thing. So therefore what can we write? Therefore limit x tends to a, f of x is equal to L. That means limit of f is L at x is equal to a. So in this way we proved the theorem. Okay, thank you. Bye bye.